All right, now the difference in this question is this is asking for the absolute, it doesn't say it in the directions, but it says find the maximum and minimum value of this function. Earlier in chapter 1, we talked about global max and min, or absolute max and min. Okay, that's what this is asking for. Find the max and min value. Now we care about the output. We want the highest point and the lowest point. Well, earlier in this section it says this, that local max and, or global max and mins are going to happen either at your stationary points, okay, or at your endpoints. So these problems will always be on a closed interval, or almost always be on a closed interval. In other words, in this problem, my highest point's at my right endpoint and my lowest point's at my left endpoint. Now I could have had this scenario. I could have had this scenario here, where the highest point was actually here at my stationary point. Now you can think about it as much as you want, but you will not be able to give me, assuming we have a nice continuous function, you will not be able to give me a situation where the highest point is not either at an endpoint or at a peak, a stationary point, okay, a local max. So what we're saying is, this tells us where to look. If we want to find the max and min values, we only have to look at those places, the endpoints and the stationary points. This is what I call, we're going to make a list of candidates. The only possible places that we can look for the max and min values are at those places. Those are our candidates. So, stationary endpoints are easy, right? They gave us those, -1 and 2. All right? Now, what I care about, remember, are the y values. So, all I care about here, here's my list of candidates. I'll just start it down here. My list of candidates, I'm going to want to know f of -1, and I'm going to want to know f of 2. Okay? I'm going to want to know the outputs at the endpoint so I can see which is the biggest output, which is the smallest output. Notice we didn't plug anything in to f in the last problem because we didn't care. We just wanted to know where the local maxes and mins were. But now the global max and min, we want to know what the outputs are. Now I need to know my stationary points. How do I find my stationary points? Find f prime with our shortcuts. So what's the derivative of 1? 0. What's the derivative of 2x cubed? 6x squared. Minus the derivative of x to the 4th. 4x cubed. And then I'm going to set that equal to 0. This is going to find my stationary points for me. So I can factor out a 2x squared, leaving me with 3 minus 2x. Now, where does this one equal 0? Where does 2x squared equal 0? When x is 0. And where does this one equal 0? 3/2. If you have to go off to the side to solve it, you can. Add 2x over to the other side, divide by 2, you get 3/2. So at 3/2. Okay, those are my stationary points. Those are going to be my peaks, my valleys, my local max, my local mins. But now I'm not going to make a sign chart here, because a sign chart for S prime tells me when the graph's going up and when it's going down, so that'll tell me if they're local max or local mins, but I don't care about that. All I care about is what is the highest output in this function in this interval, and what's the lowest output. So what I've said, according to the book, is these are the only places they can happen, is at the stationary points at the endpoints. So I'm just going to check the y values there. So I'm going to check the y value at 0, and I'm going to check the y value at 3/2. Now, if this is on the no calculator quiz, remember we got to plug these back into f. This could get a little bit tricky. There might be a little arithmetic here. We're running out of time, so we won't go through it all. Let's use your calculators. Now, as you're getting your calculators out, let's plug these numbers in. I will say this. If this was on the calculator part of the test, you would have to have all this same work on your paper.
Like a calculator?
Okay? If this was on the calculator part of it, you would have to have this derivative here. You'd have to have it set equal to 0. You wouldn't have had to factor it. We'll talk about this tomorrow. You could have let the calculator solve it for you. That would have been okay. So you could have maybe skipped this step. The calculator could have solved and gotten you the 0 and 3/2. Okay? But you have to still write down your list of candidates. Now you could use a calculator to plug those numbers in, which we're going to do right now. On that other problem we were just doing, you'd have to have all that same stuff. You couldn't have graphed it and saw where the local max and mins were. You'd have to have your derivative set equal to 0. You'd have to have your sign chart. Now you can use the calculator to plug in some values to help you there, but all that same work would have pretty much been on your paper. because you get points for each one of those things being there. All right, so what do we get when we put negative 1 in? I can do 0, get 1. What do you get when you put negative 1 in? Negative 2. What about 2? 1? Really? Wow. Okay. What about 3/2? How much? 2. We got to go 3 decimal places. You agree with that? Somebody else agree with that? Okay. So here's what you do. They ask for the global max and min value. So what they want now is the output. So right here, I'd say there's my global max, or you could just say your max. I wouldn't circle the whole point. I just want the y value. And my minimum, my global min is right there, negative 2. So the minimum was back at the left end point at negative 1, and my maximum was at this stationary point right here, 3/2. Now, if you would graph this from negative 1 to 2, do a zoom fit, you should see that those would agree. But this is using the derivative and using the ideas in the chart, using equations as opposed to using graphs, which we did the